All right, so let's start this way. What you're looking at is an image of a girl playing soccer, and she's kicked the ball. And you guys see that yellow parabola, right? Yeah. Now, the equation to that is up at the top. It doesn't really matter right now because that's not the important part. The question here is, how high did the ball go when she kicked it? So, I understand a lot of people want to just right away and do some math and just kind of jump into it. But if you stop and think about it a little bit, it's going to make more sense this way. Can you guys close the laptop, please? Sorry about the 3/4. I just learned that people are really good at still using them at 3/4. I know. I don't know. That's amazing. That's impressive. But anyways, it is impressive. Aw, thanks. So anyways, the question here, let's just think about this for a second. We have a parabola. Where is the highest point on that parabola?
Right there, the curve.
The vertex?
What's it called?
Vertex.
It's the vertex, right? And where is the vertex as far as the thing is concerned? It's where? Right in the middle, right? Now, if you take a look here, the distance that the ball covered was 90 feet, right?
Yeah.
So where is the middle?
45.
45. So if I go over to 45, then I know that up here is where the vertex lives. So I know that when x is 45, that's going to be the highest point on this parabola, hence how high the ball went. Now that I have an x, and I have the equation, what can I do with that 45? Plug it in. And what should it spit out?
Your y.
Y, which in this case is how high the ball went. Make sense? Math. Questions on that from anybody? Anybody? Questions? Preguntas? No? Cool. So, that's kind of the approach we're going to take to today's section, which is 4.2 standard form.
Yes.
Just got a life. Something different about you. I'll figure it out. Your hair. So that's what we're doing today. We're going to get equations of a quadratic in standard form. You guys see the upper right hand corner up there?
Yeah.
That is standard form. It goes ax squared plus bx plus c. Okay? Now, you guys on the book, you guys were looking at question number 1, right? Yeah. Actually, yeah, question number 1. Which ones were the only ones that were in standard form?
The first one.
Only the first one. Only the first one was in standard form. The second one is a line, but it's not in standard form. A line in standard form reads ax plus by equals c. The second one is actually in which form? Point slope. It's in point slope form. The third one is in slope intercept. And the last one has no form at all. It's just bleh. Okay? So, just want to throw that out there. Looking at the last one, which two images were quadratic? The second and the fourth one, right? Good. Now, I've got this slide with a bunch of information. It'll be on YouTube if you want to look at it, but it's already in your book as well. If you go to the next page, which is page 87, right in the middle, there's a little block that says take note. They've taken the notes for you. That's exactly what's on this slide right now. Now, if you look at those, they're not going to make much sense right now. So I'm going to walk you through and explain to you all the different things that are on there so you can kind of go through the flow, I guess you could say. Okay? So, let's get started with the next slide. Here is a quadratic equation in slope-intercept form. Now, I think that by now you have figured out what the very important thing is, what the most important thing is about working with quadratic, sorry. And what is that important thing? The vertex, right? The vertex is kind of like your starting point for everything. Where it went up, went down, whatever it did. So, what we're going to do is we're going to figure out where the vertex is. Now, do you guys remember how it was easy to find the vertex here because we found the middle?
Yeah.
What is the name of that line that goes right through the middle?
Symmetry.
Beautiful. It's called the axis of symmetry. So I'm going to give you something right now, and it's in those notes, that little block I told you, and it reads like this. X is equal to negative b divided by 2a. That, my friends, is the equation to the axis of symmetry. No matter where it's at, If you plug in A and B in there, it's going to give you the equation to the axis of symmetry. So, if you guys remember from Algebra 1, this is A, this is B, this is C, correct? Please don't take notes right now. Just watch. I'll let you copy to your heart's content when I'm done. Okay, because I don't want you to miss anything. That is A, that is B, that is C, correct?
Yeah.
So, when I plug into this, what goes on top? 8. What goes down here? 2, right? So that's going to give me negative 8 over 4, which means x is equal to negative 2. What does that mean? That means, go ahead. Well, somebody was saying what it meant. Never mind. If I go negative 2, the axis of symmetry is on that line. Sorry, the axis of symmetry is that line. Okay? Now, why is that line important?
That's the middle of the thing. That's for the vertex.
The vertex has to be on that, right? It has to be on there. Now, I don't know where it's at. It could be right there, but it could be here, here. It could be up there. It could be down there. I don't know where it's at, but it has to be on there. Somewhere, exactly. Which is good because now, at least I know, if I'm going to find the vertex here, what is the x-coordinate?
2, negative 2.
It is also negative 2. Does that make sense? So now I just need the y, don't I? Question. I have x. How do I get the corresponding y? You plug it in. Can I get rid of these notes here? Okay, so going, gone. So 2 times something squared plus 8 times something minus 2. And what goes into that something? Negative 2. Negative 2, negative 2. So negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is a negative 16 minus 2 more. I've got 8 minus 18. Looks like we got negative 10. So over here, my vertex, my friends, is at negative 2, negative 10. Let's pretend that that's it right there, okay? Make sense? Now, just by looking at that equation up there, is my parabola facing up or is it facing down? It's facing up because A is not a negative. A is positive, okay? Now, if this was Math Excel, I would need one more point in order to graph this parabola, right? Yes, no? Okay. Do you guys remember back then when we were doing lines, we would start at a very important place. What was it? Not 0, 0. We called it the y something.
Y-intercept.
Yeah. And where was the y-intercept always? 0, comma
1, 0.
0, comma b.
Oh.
You guys remember that? It was 0, comma b, and we could go to the end of the equation, find what the value of b is, and we say, oh, that is 0, comma b. Here, we don't have a b, do we? Well, we kind of do, but it's not the same b. When we're working with a quadratic, your y-intercept will always be at 0, comma c. 0, comma c. A y-intercept happens when the x value is 0. So take a look. If this was 0, what happens to that whole term?
0.
It's 0. It's gone. If this was 0, what happens to the middle term?
0.
It's gone, right? Which means I end up with the constant of
2.
negative 2. So my y-intercept is at 0, comma negative 2. 1, 2, put a point there. And of course, how far is that away? 1, 2. So 1, 2 this way. I should have another point close to that. And there is my parabola. Okay? That was a lot. That was a lot really fast. Questions on any part of it?
Where's 2 plus 8?
Copy this. It's in your notes. I'll put it over here. The formula for the axis of symmetry is x equals negative b over 2a. Negative b over 2a. so did I. But I'm not bragging.
Sorry.
You want to see a parabola? Want to see it again? You look so innocent.
Ooh, are those puzzles hard?
Give me your hand.
All of us. I'm gonna take it. I'm gonna take it. Action. Oh, I thought about bounce out. Oh, yeah, there we go. My phone? There you have it.
Hmm?
You put it under your.
Wow, man.
Yeah, I noticed, but I wasn't gonna say nothing. I don't need it. He saw you go. No, you can leave it up then, because they're gonna.
Oh, he just gave it to me, guys. You hear that, right?
Yeah.
And it's recording. You can have your headphones though.
Nah.
You can get a new phone for that.
You can sound more like
Yo,
regular.
wait, is this the plus?
Yeah. It doesn't feel like the plus is this one. No.
Only in an iPhone. Like, this is plus. In Android, it's standard.
Yeah.
Feels nice though.
I know. Makes me look good.
Questions? Moving on. Let's do it again. Oh. Okay. Ready? Okay, first thing that I want to do is find the axis of symmetry. Because that's going to give me parts of the vertex, right? I'm going to just put my vertex right here. Axis of symmetry. X equals negative b over 2 times a. B is 2, a is 1. That means that my axis of symmetry is that x equals negative 1, right? So, guess what goes right here? Negative 1. So, let me go ahead and sketch my axis of symmetry real quick. Oh, there it is. It's in pink. You see it? Blah, 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 blah. Now, to get the y part, what do I need to do with that negative 1? Plug it in. So, I've got negative 1 squared plus 2 times negative 1 plus 3. That makes 1 minus 2 plus 3. That means I'm going to get 2. So, 2. Right? Graph that point. Negative 1, 1, 2. Is this parabola facing up or is it facing down?
Up.
How do you know?
Because it's positive.
What's positive?
No.
The a value is positive. The a value is positive. Okay? So I've got that point. I need one more point to graph this. 0, 3. 1, 2, 3. That means I should have another point just like it there. And there, my friends, is my parabola. Simple enough? Now, let me go ahead and let you copy that first. Yeah.
You.
No. Yeah.
You. Austin wasn't in class today, huh?
I don't know
ISD.
what to say.
I'll yell at him for you.
Hiya. Hiya.
I'm gonna take it. I'm gonna pick you up. Blow it up.
Sapo verde. And 1, and 2, and
You're not sounding too much of that.
Yeah, they have to.
Yeah, but like,
I'm like, why go to Chick-fil-A?
They'd be like, okay, let me take you.
yeah, but like, she's talking about like during an interview. Isn't it like?
They want you to smile.
Yeah, because you're interviewing. They want to know what you're gonna be like. You gotta fake it, bro.
Yeah,
Fake it till you make it.
Sometimes that's what it does.
Oh. Not at Chick-fil-A. You gotta be all like, I love this job. And
Like, I love everybody here.
I love the hamburgers and I love the bread. I love this cup. Thank you. Thank you. Thank you. Before I move on, I'm going to try something else. It's called a fist to 5. So on scale from 0 to 5, how well you got this? Do you have it nothing? Or I really got it?
I got a trust.
Okay, Angel, put all your hands down.
No? Are you serious? It's not too bad? I'm looking for those 2s and 1s. Okay? So, which part is confusing you? Which part do you not get? Can you get the vertex?
Yes, I got it.
Huh? Never mind what? Which part? The axis symmetry? Oh, well that's easy. This is A, right? What number is right here? 1. This is B, and this is C, right? Look at A. If A is positive, it's happy. If A is negative, it's sad. That's simple. So, that help? Cool. Now, I want to make sure that everyone's got, or the majority of people got this fairly decently because, what's up? Uh-huh. How did I get it to go up to here? Do you remember how I got the y-intercept? No. Well, I said I did. Y-intercept is at 0, comma, C for a quadratic, always. So which one is C? 3. So I went 0, 1, 2, 3. Got this point. Now, at this, from here, I know that parabolas are symmetric, right? So here's what I thought. If there's one point right here, there should be one on that side as well. And that's how I got the other one. I didn't even do no math. So if you think about it, let's say I had a point right here. That is 1, 2, 3 away, right? I would have to go 1, 2, 3 away and put another point there because of the symmetry. Okay, thank you. All right, let me get rid of this. Let me get rid of that. Okay? So, did that answer your question, how I got those other points? Okay, cool. So, thank you. This was not so bad. Looks like most of you guys got it with the 4 or 5. Now, you know, the form that you're looking at right now is called standard form, right? And the one that you guys remember, the ones we worked with before, the one that was that had A, H, and K in it. How many people already know they're gonna make you go from this one to the other one, right? Oh yeah, roll my eyes. I'm gonna take that one. Yes. So they're gonna ask you guys to convert from standard form to the vertex form. Okay? Well, let's take this step by step. What are the 3 things that we need in order to do the vertex form? We need H, K, and A, right? So let me write those down. I'm going to get rid of this work here. So I need A, I need H, and I need K. Because I have to write y equals A times x minus h squared plus k. Now, question. We already found the vertex, right? So what is h? What is k? That was easy, right? But how do we get a? No. Nice and loud? It's already there. What is a? What is a? 1. Look, we're done. So if we want to write this in vertex form, then we just go y equals x minus, oops, that's minus 1. So that's a plus 1 squared plus 2. Math. Okay. What's up? Simple enough? Yep. I got a light. Yay.
I think my brother is famous, right?
Music? I grew up with it. Huh? I think it's a Disney thing. Oh!
I know, that's like, we're about to go. That's how it goes.
Okay. Well, that's still homework. Oh. Oh, that's it. I'm done. Let's do this real quick. I'm going to give you guys about 5 minutes. I want you guys to do problem number 2 in your books, please. Problem number 2. It's on page 87. Yeah, problem number 2. No, I mean problem number 2.
What page number?
Problem number 2.
What page number?
Page 87. Not question 2, problem 2.
Mine was so compassionate. Damn, where my tennis ball go?
Pásame el bolón.
Oh, that's the bottom. Oh, damn. Where's my tennis ball? Right there.
You're thinking breakfast club. conversation's going on, I'll give you guys some time at the end. That is the whole thing. I want to answer your questions so that they're on the recording as well. So, what were your questions on the homeworks?
I think it was like question like.
So we're gonna be on
It was
YouTube.
question
You
9.
don't want to tell me that.
Not like I couldn't do it.
Actually, Mika, can you just tell me?
I don't know what it is though, but it's one of
Is it
My
one
famous sister?
What?
That's how, okay.
Anybody need 1, 2, 3, 4, 5, 13, 14? Okay. 14.
I know, even eat a hot pocket.
No, they're, well, I'm not going to say they're not hard. When I saw it first, it stumped me. Thank you. The thing with math, and I don't know if you figured it out yet, but everything builds on what you did last year and before that. It even builds on what you did last month. Okay? So you're getting skills that are going to help you later on with different types of things. For example, in this problem, they gave us an equation here that says this is the model. Y equals a times x plus 1 squared plus k. And that a looks weird. Look like my nines.
9 on my waist.
Okay, so it looks like that, right? Now, they gave me 2 coordinates. I don't know if either one of them is the vertex. And they don't tell me it is either. So there's no way that I can use it as an H and K for a vertex. Actually, I can actually throw that out. Because you see here, this is saying that H is how much? How much is H? It's -1. Do either one of those 2 coordinates have a -1 in it? No, therefore they are not the vertex. You see that? So, here was my thought. Here's what I did. I said, all right, well, I do have this model they gave me. There is an x and a y that I could replace, right? For example, here, if that's 8, x is 1 squared plus k. And then if I do it again with this coordinate, that would be -17 equals a times 2 plus 1 squared plus k, right? Now, you might not recognize it right now. I'm going to clean it up a little bit. This is going to be, let's go with the green again. 8 is equal to, what's 1 plus 1? What's 2 squared? So that is 4a plus k. Looking at the blue one, -17 is equal to, what's 2 plus 1? 3 squared is? So that is 9a plus k. Does anybody see what we're working with now? Right here. What is that? I've just created a system of equations. I just created a system of equations. Which one would be the easiest one to get rid of?
The first one.
The k's. The k's, bro. The k's.
So you meant like which?
So if I did this, if I just said, all right, negative, 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 wouldn't the k's just drop out? Yeah, so what's -8 minus the 17? -25, right? And what's 9 minus 4?
5.
And k's are gone. So I divide both sides by 5. Guess what the value of a is?
-5.
-5. How do I get my k? Plug it into what? What are the first equations? I'll use the top one because they're smaller. That is 8 is equal to, what is that, -5?
Wait, yeah, 5.
1 plus 1 squared plus k. What's 1 plus 1? 2. 2 squared is 4 times the -5 is a -20. Let's add 20 to both sides. So that means that k is, and I'm done. Man.
Give my brother's
Yeah,
ball
isn't it a
back.
lot to think about? It sure is, but what are you supposed to
Give
do?
my brother's ball back.
That's the point. You're supposed to think about it.
Give my brother's ball back.
Here we go. What is it? -5 and 28. So -5 was here,
I'm not playing with you, dog.
and then you're on the right.
I give my brother's ball. Give my brother's ball
Oh, 28. My bad. My bad. I'll put a 25. Woo! Yeah. You guys can see the word? There's the word.
How do you think it broke? How do you hit something, dog?
I'll do 15 and then you can do 60 because it's the same thing. Okay?
What?
Yeah.
Hey, think fast. Huh? I know it would have hit you in the head. I would have got in trouble.
No.
Like you would have yelled. Like, why would you throw that?
Now I'll just be like 3 push-ups. Yeah.
I can't do push-ups.
Because if I don't catch it, you drop it. Oh.
Damn.
Yo.
Yo. How about those? That's
Don't throw it out. It's going to get lost in this air.
Well, let me see that.
Oh. It's safe for a little bit.
Whatever. Because I know you gotta like flip it around. I was trust. It's like a little bird in a nest. I'm telling you.
You won't leave it.
You want brother's ball back?
Hold on. Did you just drop the ball?
Yeah, he dropped it.
Okay. We're good here?
Yeah.
You want brother's ball
Yes.
back, Mr. Munoz?
No?
You want brother's ball back?
Oh my god, what's wrong with you?
Oh my god.
She's crazy. That doesn't happen.
3 push-ups. No ghosting.
I think that's probably all I could do, man.
What? 3 push-ups? I don't think I can do any push-ups, Loki.
Honestly, I can never do push-ups.
The only thing I'll be pushing up is that spoon in my mouth.
Ooh.
After having some soup.
The only thing I'll be pushing is these carts.
Ah, that was good.
You take a lot out of me though sometimes. Like pushing like 15 carts. That's a lot.
Where at?
Safeway?
Oh, I love Safeway.
You never shop at Safeway though.
Yes, I do.
I don't. I
Just
never
not when
see.
you're there.
I always work.
Always work.
Yeah, I never work.
They give you like 5 hours, 1 hour every day.
No, they gave me like 8 hours this week. I'm so pissed. Yeah.
You know what I did right now? Don't worry. Just enjoy being young. I
I've been
did
working,
it,
I've
and
been
I'm like,
working since
man.
like my 16th birthday. Like I literally only wait. Like I waited like a week after my birthday.
You know what? That's true. When I was 13, when I was 13, we were 13, and we were like, Dad, can we get White Sox? Like, you can buy your own White Sox. Send us to the fields. It's all good.
It's like I don't know. It depends
Learn how
what
to
you do
work?
in the fields. Yeah.
Huh?
It depends what you do in the fields. Like how bad it is. Like my homie Jose, my other homie Jose. Not Dennis.
All right, now time. Let's go. We'll finish that in a little bit. We'll finish that in a little bit. Ready?
Just pick watermelon.
What was the other one? 15, right? Here we go. That's 14. Here's 15. I thought this one was just like the last one we did, and it's not. It's not. Because I was trying to do it just like the last one. I remember somebody asking me second grade. I said, "Oh, it's the same thing," and it's not. And I thought this was such a cool problem because I tried to do the system thing, and it just gave me quadratics, and you have to work with quadratics, and you still could not solve it. So I'm like, well, what else could I do? Now, so here's one thing that I noticed. Do you guys see that they gave us a model? They gave us y equals a times x minus h squared, correct? And then I saw the second coordinate, the 2 comma 0. I said, all right, well, if I plug in that coordinate, 0 is equal to a times 0 minus h squared, right? Wait a minute, what is that? Not a 0, 2. Why y'all say something? Right? So, do you guys see what I just did? I just plugged in x and y, right?
Yeah.
Now, at this point, I just algebraic. I just did algebra on this. I want to get h by itself, so I divided both sides by a. A over a becomes 1. What does 0 over a become? 0. That gives me 2 minus h squared. How do I get rid of the square? Square root both sides. Ba, ba. So what is the square root of 0? 0. So I got 2 minus h. All I did was move h to the other side, and guess what h is equal to? 2. How do I get a? Plug that back in. So I went, and I got that function again. Y is equal to a times x minus 2 squared. And I plugged in the other coordinate. What's the other coordinate? 4 comma negative 2. So negative 2, 4 squared. So I've got negative 2 is equal to, what's 4 minus 2? 2 squared is? So this is 4a. Once I divide both sides by 4, a is equal to negative 1/2. Algebra. It looks so unmysterious when it's done, huh? Right? Like, that's not as cool as I thought it was going to be. Math don't like hard, peeps. Math don't like hard. And 16 is exactly the same as this one. I checked it this time. Okay? That's time. I'm going to stop this.